Hey, this video is going to help with topic 1 of 6th grade, and I'm going to give you some problem-solving examples from section 1-6. And this section kind of uses all the word problems and the realistic problems that you can use everything we've been learning from, and it throws it into one section. So there isn't always a video available. It's just like you're supposed to use what you've been learning. But I want to make sure, especially for the first time we're doing something that's in the problem solving, that I made a video to help you be a little more successful. So let's look at this first example here. A bar diagram can be used to represent an algebraic expression. To make a bar diagram, draw a bar and divide it into 2 pieces. Then label the pieces. So we have a bar and they have drawn the little line that divided it into 2 pieces, and let's read where they got these n and this 32 from. That's their first example. It says write an algebraic expression for the word phrase a number plus 32. So anytime we see a number, we should think, oh, that's where I put the variable, and I usually use an n for a number because it's n number. So that's where they get n plus 32. And in a bar, it's n plus 32. So the next example here, the subtraction model says, write an algebraic expression for the word phrase 16 subtracted from a number. So the expression would be 16 subtracted from a number. That means the 16 has to go after because you're subtracting it from n. So be careful of the wording on subtraction because you can mess up the direction. With addition, you can add any way and you'll get the same answer, so it's not as picky as subtraction is. Okay? And then they did a bar diagram here saying the whole thing represents n, a number, and then n minus 16, and then they have a 16 here. And I kind of don't like this. So their logic is 16 minus 16 would give us n, and that's where we'd get that n value as the whole thing. I kind of would prefer they use a different kind of model, but I'm going to show you what they came up with for the book so that if you see one like that, you'll know what they're talking about. They want this to end up being n as their bar. All right, let's do another example down here. A library had X number of bibliographies and bought 13 new bibliographies. What algebraic expression can be used to represent the total number of bibliographies the library has now? Okay, so we have X, right, number, and then we bought 13 more. What mathematical operation are we using? Add, subtract, multiply, divide. Right? We're adding that. So how can I write an expression? I'm covering the solution. I can write the expression as X because they want you to use the letter X. An N would have been fine, but they want us to use an X. So I would just say X plus 13. So you have to read the problem and decide, well, am I add, subtract, what am I doing? And then you write the expression. And then again, they did a little bar diagram there for it, but it's just X plus 13. Let's see. I wanted to do one that had a multiplication. Let's see. Suppose I'm going to do this one right here. Oops. Suppose each page of the photo album is designed to hold 4 photographs. So each page had 4 photographs. And an album can have P number of pages. So we don't know how many pages this thing has. It has P, but we know it holds 4 for each page. Well, if I want to figure out, let's say it had 20 pages, how would I find that answer? I would multiply by 4 because that would give us the 4 for each of the 20, or you could do repeated addition for 20 times, but that's why we have multiplication. It's repeated addition, right? So we would take 4 times P, or 4P, as our expression that they give you right here, 4P. And this is kind of how they represented it in a bar. They said 4, and then they times it by the P. Again, it's okay. I prefer just thinking of it as 4P or 4 dot P, 4 times P. And we do want to start using the dot and not the X as much as we can, starting really at this level. So division always brings in this word quotient, and that confuses people. Multiplication brings in the word product. So if you see those words, product is multiplication, quotient is division. But let's look at a division question here. Suppose a company that manufactures the photo albums is packaging them for shipment. Each shipment box holds 12 albums. The expression representing the number of boxes needed to ship. So what is an expression needed for the number of boxes? So each shipping box holds 12. I don't know how many boxes, right? So I'm going to take the number of boxes, or yeah, the expression, right? I want to do representing the number of boxes needed to ship is X, number of photo albums. It's going to be X divided by that 12, because each one's going to hold 12 albums. So I'm looking at their little representation. We have the number of boxes is 12, or the number of albums. I keep wanting to say it backward. The number of albums in each box, and we don't know how many boxes or albums, so we have to divide to get that. And this is what they use to kind of draw that out, is here's the total number in all the way across, and then they have 12, and they say, well, I don't know how many boxes, but we know 12 is in each box. Okay, so we could use division if we knew how many boxes, or to find the number. All right, so I think those were the only ones I wanted to go through. Some of the questions that you find in here, and especially when we start looking at those challenge questions, those are going to be a little bit harder. And I just want you to do your best and try them. You have the answer key to help you see if you're getting them right, or maybe to help you be like, what did I do wrong? All right, so make sure you go through those. You can skip a couple problems in the problem solving. You should get an idea of writing those expressions still from a word problem, and maybe understanding a little bit of what they mean by those boxes and representing those visually when I add, right, or subtract or multiply. Anyway, hopefully this video helped you a little bit with this section.